Covalent bonding. This covalent bonding occurs by sharing outermost electrons between neighboring atoms. So the covalent bonding occurs by sharing valence electrons between neighboring atoms. So this bond is formed by two electrons. This is formed by sharing two electrons, one from each atom. Which are participated in the bond. So between the two atoms, the electron pair is shared. In the electron pair, there is one electron from each atom. They form an electron pair. And these contributed electrons are shared equally. Usually they are shared equally and belongs to both atoms. We cannot say that this electron belongs to this atom like that. Both the electrons are shared equally and both electrons belongs to each atom. Because of that, what happened? Both the atoms which are forming covalent bond between them are neutral even after bond formation. Both the atoms are neutral. Because of this covalent bond, that is when the electrons are shared equally between the atoms involved acquire configuration of noble gas. Acquires configuration of noble gas. And we know that this noble gas are stable because they have closed structure. Simple example of this covalent bond is hydrogen. Simple example we will take here of hydrogen. You know that this hydrogen atom has one valence electron in shell. However, the capacity of shell is 2 electrons. 2 electrons. But it has only 1 electron. Its capacity is it can accommodate 2 electrons. So because of this, what happened? Each hydrogen atom want to pick up second electron. Each hydrogen atom wants to pick up second electron. to get the closed structure. So in an effort of picking the second electron, what happens? These two hydrogen atoms reacts and form hydrogen molecule. In an effort of picking second electron, these two hydrogen atoms reacts and form hydrogen molecule. So if I want to show you the diagram for this is the hydrogen atom, and when they react, they share electron. Here is the nucleus. This electron pair is shared between these two atoms. So this electron pair, what happens? It spends its maximum time in between two atoms. So what I have shown over here is this H atom, hydrogen atom share each other electrons, share each other's electron and form a single band, form a single covalent bond. In a single covalent bond, there is an electron pair. Each electron pair form single covalent bond. So if you want to show this bonding using the Lewis dot structure, so here is the hydrogen atom and there is a one electron plus hydrogen atom with another single electrons gives us hydrogen molecule, that is H2. This pair over here, this is the electron pair shared by both the electrons, both the atoms. This electron pair is shared equally by both the atoms. And the pair which is forming the bond is called bonding electron pair. So that is the example of hydrogen. Take another example. Let's take another example of fluorine. You know that this fluorine has 7 valence electrons. It has 7 electrons in its outermost shells. To complete octet, it needs one more electron. To complete its octet, it requires one electron. So what happened in this case? These two fluorine atoms then share one electron each and form fluorine molecule. So two fluorine atoms share one electron each and form F2 molecule, fluorine molecule. Let me show the Lewis dot structure for this. Lewis dot structure for the fluorine is fluorine plus fluorine, and this fluorine is having 7 valence electrons in its outermost, 7 electrons in its outermost shells. So these two fluorine react and we get fluorine molecule. We have to show this electron pairs. So they form the octet. As you can see, there are 8 electrons in their outermost shell now because they are sharing 1 electron each. As you can see over here or here, they are having 8 electrons in their outermost shell now because of the sharing 1 electron each. In this case, this pair form the bond, and so it is called bonding electron pair. And there are, at least 3 unshared pair of electrons for each atom here. So there are total 6 unshared pair of electrons. These unshared pair of electrons called lone pairs. So in this case, there are 6 lone pairs. So these are the covalent bonds between two like atoms. Examples are hydrogen and fluorine. But there can be covalent bonds between dissimilar atoms also. That is, two or more atoms of different elements can also share electrons and form equivalent bonds. They form single covalent bond and complete octet to achieve a structure of noble gas. Noble gas structure is more stable. Examples are in this case, what is a single covalent bond? Single covalent bond is formed by a pair of electrons. Take the example here, in this case, H2O, NH3 and CH4. In case of H2O, as you know that there is O, one oxygen atom and two hydrogen atoms. Oxygen atom is having 6 electrons in its outermost shell, so it requires 2 more electrons to complete the octet. So what happens? It shares 2 electrons with the neighboring 2 hydrogen atoms, and so they are forming 2 single covalent bonds. So in this case, there are 2 electrons which are forming 2 single covalent bonds. So there are 2 single covalent bonds in this case. In case of nitrogen, nitrogen is having 5 valence electrons. So to complete the octet, it forms 3 single covalent bonds with hydrogen atoms to get the octet structure. Similarly, in case of CH4, carbon has 4 valence electrons. To complete the octet, it requires 4 additional electrons. So it shares its 4 electrons with 4 hydrogen atoms. Each bond is having 2 electrons. So in this case, there are 4 single covalent bonds. In case of NH3, there are 3 single covalent bonds, and in case of H2O, there are 2 single covalent bonds. So what I mean to say is, for every shared electron pair, single covalent bond is formed. For every single electron pair, one single covalent bond is formed. But some atoms may share 2 or 3 electrons. Some atoms share 2 or 3 electrons, forming double or triple bonds, covalent bonds respectively. Let me take here the example of oxygen. Oxygen. This oxygen is having 6 electrons in outermost shell, or I will say it has 6 valence electrons. It required 2 electrons to complete octet. So, to attain a configuration of the neon is the noble gas. So to obtain the configuration of neon, this oxygen atom require 2 more electrons. So to get it, 2 oxygen atoms react by sharing 2 pair of electrons. And form double bond between them. Double bond is formed. When there is a single electron pair is shared between the atoms, it forms a single covalent bond. But in this case, 2 electron pairs are shared and so it forms a double bond. So this oxygen plus oxygen gives us double bond between them, that is O2. There is a double bond between the oxygen atoms. Another example is nitrogen. This nitrogen, as you know, there are 5 valence electrons. 5 electrons in outermost shell. To complete octet, each needs 3 electrons. So in this case, 3 pair of electrons are shared between two nitrogen atoms and it forms a triple bond. So if you say N plus N gives you, there is a triple bond between these two nitrogen, that is N2. And obviously, the strength of the bond increases with multiplicity. It means that triple bond is stronger than double and single bond, or you can say double bond is stronger than single bond. So that's how the covalent bondings are formed between the like atoms or between the unlike atoms. Depending on that, there are two types of covalent bond. We can differentiate it into two types. One type is non-polar covalent bond, and another type is polar covalent bonds. Let us see the difference between these two. Non-polar covalent bonds form between two like atoms. They form between like atoms. However, these polar covalent bonds form between unlike atoms, or let's say dissimilar atoms, or unlike atoms. That is the first difference. Second difference is electrons are equally shared in the bonds. Let's say electron pair equally shared by both the atoms. But in case of the polar covalent bond, electron pair not equally shared. That is the second difference. Then the third difference is obviously electronegativity of both atoms are equal because non-polar covalent bonds are formed between the like atoms. So obviously their electronegativity is the attraction towards the electrons. So electronegativity of both atoms is equal. Now this polar covalent bond is formed between the two different atoms. So obviously electronegativity is different. So since the electronegativity is different and electronegativity is nothing but the attraction towards electrons. Electronegativity is different means one of the atom may be having more electronegativity than the other. Result of that would be this bonded pair of electrons are drawn more towards high electronegativity atom. One of the atom is having high electronegativity, so this electron pair is drawn or attracted more towards high electronegativity atom. Because of that, let's say hence, that atom develop partial negative charge on it. The atom which is having higher electronegativity, that atom will develop a partial negative charge and equal amount of positive charge is developed on other atom. So this molecule so formed will be polar. One of atom will be having negative charge, partial negative charge, other will have partial positive charge. So they will form a dipole. So they form dipole. An example in this case is H2O, HCl, HBr, etc. But in case of the non-polar covalent bond, what happens in this case? The molecule is neutral. Molecule is neutral because shared electrons, this electron pair, are equally shared by both the atoms. And so the molecule is neutral because here center of positive and negative charges coincides. And so the molecule is neutral in this case. But in case of the polar covalent bonds, the molecule is not neutral. One of the atom will have negative charge, partial negative charge, and other atom will have partial positive charge. And in this case, example are simple like H2, F2, Cl2, etc. So this is the difference between, let me here take the example of H2O, oxygen and two hydrogen. Electronegativity of oxygen is more compared to hydrogen. So electrons pair are shifted more towards the oxygen. So this oxygen develops partial negative charge and hydrogen develops partial positive charge and they form a dipole. So we call it polar covalent bond. Now let us see the properties of this covalent compound. Properties. This, this covalent compound are in the form solid, liquid, and gases. They can be solid, they can be liquid, or they can be gas. If it is a solid, then it develops a crystalline structure. It has crystalline structure and have strong directional properties. Covalent bonds are directional bonds. Covalent compounds are insoluble polar solvents, but soluble in organic solvents like benzene. Electrical conductivity of these compounds are poor. Electrical conductivity is poor. You can take the example of silicon germanium. Its electron conductivity is poor but can be increased by adding the impurity like a extrinsic semiconductor. Then melting and boiling point, weak compared to ionic solids. And these compounds are very hard as atoms are strongly bound with each other. Atoms are strongly bound in lattice structure. So they are the hard, and the hardest material is a diamond because this carbon-carbon covalent bond is very strong.